Welcome to
Wait a minute, I can see a lot of data visualization there. I'm wondering, why is the environmental data so important? Let's ask someone from my NASA data. Hello, Miss Desiray.
Hi, Nikita. How are you?
I'm great, and I'm so excited to see you. I'm so
Excited to
happy
be
today.
here.
And I want to say hello to Sobat Kokamuhi everywhere you are, and thank you for coming to our show. So, Miss Desiree, today I just saw your website, my NASA data. So I also saw that you are one of the team there, and you are scientific programmer there, right? And
I am, yeah.
and I saw that the visualization is really interactive, and I have fun, and that is so engaging for me. And can you tell us about what did you do during the development of my NASA data project to us?
Yeah, so what I work on my NASA data, I do a couple different things. Most
Mm-hmm,
of it is GIS and working with
mm-hmm,
data. So GIS stands for Geographic Information Systems. And
mm-hmm,
really all that means is like location-based data. So
mm-hmm,
like satellite data, remote sensing, anything that has to do with maps. And so NASA has a whole bunch of satellite data. We
mm-hmm,
send satellites up and they go and monitor the Earth and produce a lot of data. And so what I do is I take that data and I try to put it in formats and things that help teachers and students learn about Earth science. What I do is I spend a lot of time building web applications and things
mm-hmm.
online to help people to analyze and visualize this different satellite data.
Hmm, that's interesting. Yeah, I saw there are a lot of geographic informatics system thing there, and I did uh moving the slider and like looking at the urban heat island data, like land cover classification, and then land surface temperature, and the other thing.
Mm-hmm.
Mm-hmm. But I'm still wondering. So, I saw that in my NASA data, they use a lot of environment data. But why environmental data is so important for us? As we know, we have skin to sense the temperature, and then eyes to classify maybe land cover. But why is environmental data is so important for us. Can you share the reason with us?
Yeah. So I'm going to real quick share my screen. But to
Mm-hmm.
start, um, so you bring up a good point about how we use our senses a lot of time to understand the world around us.
Mm-hmm.
And that's one way of collecting data. But what satellites and instruments and other types of technology allow us to do is to collect data um, more than just from our senses, right? So we
Mm-hmm.
get to observe things that may not always be observable with our senses. So here on these slides, I've got some reasons for why environmental data is so important. And so we're going to go through these real quick. But the first is that environmental data allows us to monitor and create like a long-term record of these different environmental variables. So different indicators, things like air quality, water quality, temperature, vegetation, biodiversity, we can, using instruments and other data collection methods, we can begin to track and monitor these things. And that helps us observe different changes in the environment. So it's really important. Again, satellites keep a really long-term record, and that is great that we can use that now to help identify these changes. We can look at the Earth at different scales. So we can look at things at both a large scale and a small scale, and continue to keep that record. And then it allows us to really assess our environment in a way in which we've never been able to do before. So instead of using just our eyes or just instruments on the ground, we now have a larger picture, and this can allow us to assess the health of different environmental factors. We can look at whole ecosystems. We can identify challenges, sources of pollution, and look at how different solutions might be implemented. Um, we can assess what potential damages might happen from natural disasters. All sorts of things can be done with data. So we are really living in a golden age of Earth observations. It's true. We have more data about the Earth than we've ever had in the history of Earth.
Mm-hmm.
So there's just petabytes of data, and we can use it to do all sorts of things, to prepare for the future, solve problems. It's really great. And it's also accessible. You've got many governments around the world, um, are able to produce a lot of data and then put it out there for everyone in the public to use and enjoy, which is great. And then, so now that we have this long-term record of data, we can use it to predict different things. We can use it to predict and manage natural disasters. So you can think of just your weather apps as one example. We can now predict where a hurricane is going to make landfall, and other weather events. And we can also predict how the environment will change over time. We're starting to understand how different parts of the Earth system are connected to one another. So, a change in one part of the system, how it could impact another. And this is used to help develop models. So, again, these predictions, we can start to model them. You've probably seen there's different like climate models, and people are really trying to use them to understand develop a more holistic view of the Earth and understand how all these different parts and pieces fit together. And then scientific data, environmental data, it's often used to help teach and communicate with others. So teachers can use data in order to teach different scientific concepts because oftentimes students really benefit from doing hands-on science and working with science like scientists do, which is working with data. And so that's one of the benefits of having so much environmental data available is that students, they're able to learn more. It's really helpful, especially for visual learners. So most of the world learns visually. And so it can be really helpful to look at different data visualizations in order to learn about some of these different scientific concepts. And then lastly, we can use these data then to make better decisions. So environmental data is often used to inform policy decisions. So now that we have this data available, we have a long-term record, we can make predictions and see through imagery how the environment is changing, that we can then go to people in our government, decision makers, and show them this data, and it can be used to help form their opinion, and they can use it to make decisions and craft different policies, put different policies in place to help either benefit the environment or learn more about it, mitigate different environmental challenges, help prepare for potential natural disasters, all sorts of different things.
Mm.
All right. And so that is a quick little slide on why environmental data is so important.
Yeah, wow, that's so insightful. And it's not just only one. And in here we have like five the reason why the environmental data is important, and that's why environment data is so helpful for us, like track and monitor, and then for the assessment, and then prediction, and then teaching others, and the last is informing policy, right?
Yep.
Yeah, that's so insightful. And maybe in the future we can do more prevention to the climate and environmental challenges from the data we get from history, from long-term record, right?
Yes. Yep.
And I, from the GLOBE program, the country that joined GLOBE program to be citizen science is getting more and more and increasing. And how do you feel with that?
Oh, I think citizen science is great. Um, those measurements, they have a lot of benefit.
Mhm.
There's a huge benefit to having people all over the planet contribute to environmental science. So
Mhm.
it's a great program, and it actually it can help validate
Mhm.
some of our satellite measurements. So sometimes
Mhm.
we look and compare what people are seeing on the ground to what the satellites are getting. So it has an application for ground truthing, what the satellites are seeing, but also there's things from that vantage point on the ground, citizen scientists all over the world collecting data that can't be seen with
Mm.
satellites. And so that data, being able to take pictures and um, upload that data to a database, that's another great way of keeping a record of the environment. And that data too can be used in a multitude of ways.
Yeah, that's great to hear that. And yeah, let's see, in the future, maybe a lot of people will be able to be citizen scientists from all around the world. And as you
Yeah.
mentioned before that most of us are visualized learner, right? And can
Mm-hmm.
you share us the example of the data visualization, perhaps maybe related to human activity or the other visualization about, yeah, climate data? Can you share this with us? So maybe we can do a project like you did.
Sure thing. I'm going to share my screen again.
Mm-hmm.
So let's go back to the slideshow. So there are all sorts of different types of data out there and data representations. So a data representation can be any type of graph or plot. It can be a map. There's all sorts of different unique ways we can show data. I wanted to show this one quick to start. This is a line graph showing the global temperature anomaly. So that's how much different the global temperature is from the long-term record. So this is
Mm-hmm.
between 1880 to 2010. And so it's showing that average temperatures are increasing over time. And but you can see there's a lot of variation
Yeah.
within this year to year.
Mm-hmm.
Sometimes there's a significant drop, but it tends to climb again. And so overall, the trend is up, but there's a
Mm-hmm.
lot of variation. But what I find so interesting about this graphic is that the data was taken, it's comparing data from several different scientific institutions. So each one of these lines is a different um, research place. So we have NASA Goddard Institute for Space Studies, Berkeley Earth. We have the Japanese Meteorological Agency, NOAA, the Met Office. And so all of these different groups took their own measurements, but yet when you put them all on a plot together, they're all so similar. So it just shows
Yeah.
that um, all of these scientists collecting the data, we can bring it together and use it to ensure its accuracy. And so shows that a lot of the leading world scientists really are in agreement about these things. And the reason for that is because we have the evidence to back it up. We have data. So I really like this graphic and I wanted to share that all with you. But this is real global data. So this is at a really, 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 really large scale. It's looking at minor variations in the global temperature. But there's all sorts of different scales of data. And so I wanted to share with you some other examples of data that could take place within your local environment, in your community. Um, any questions so far on the first part?
Hmm. I think that's interesting about the graph that you share with us. So
Yeah.
the search is from different institute, and you say that it show the accuracy, right?
Uh huh.
Mm-hmm. And that's the evidence for us that global warming is the real thing, right?
Yeah.
Mm-hmm. But how the scientists actually tell to maybe government that is the real problem, something like that. How they
Oh, yeah.
communicate this data to the government, or yeah.
Yeah, it can be difficult. So one of the best things that we can do is create graphics that tell the data story in a very simple way so that it's easily understood and digested.
Mm-hmm.
Things like graphs like this can really show what's happening really quickly. So we don't have to
Mm-hmm.
spend a lot of time, um, reading and going through all of the scientific research ourselves, and spending all of the time to do that. If we can create engaging data visualizations, it can help communicate these findings, and it can help because our governments, our politicians, they're smart people, but they might not have the same knowledge and background in science as our scientists in these different agencies. And so to be able to communicate these results in a way that is meaningful, impactful, easy to understand, that's a big job. Um,
Mm-hmm.
and there's a lot of people trying to figure out the best ways to do that.
Mm. But the key is make it more accessible and easy to understand, right? Just make it simple
Yeah.
because we are from different background. So like our government politician, maybe they are from different backgrounds. So we need to
Uh huh.
just make it simple and easy to understand,
Yes.
right?
I think that's
I
great
get your
advice.
point. And thank you for the explanation of my question.
Yeah. So I wanted to show you a few more examples.
Mm-hmm.
So this is a story map, is what we call them, and this is something I developed for my NASA data, and it's actually a lesson. So I've
Mm-hmm.
made it for teachers to distribute to students, and it's actually designed for students in grades 3 through 12. Um, and so it's about the urban heat island effect. And so, for those of you who might be unfamiliar with the urban heat island effect, urban heat island is where the cities get much more hot than the surrounding rural areas. And it's really due to cities being full of a lot of rocky surfaces that absorb more heat, um, com- compared to vegetation. The vegetation outside of the cities is going to be a lot cooler, because they don't absorb as much heat as cities. So it can mean that inside in the city, it's a lot more hot than you'd expect it to be. And
Mm-hmm.
this can cause problems like people can suffer from heat stroke. And so it's something that cities are currently dealing with. And so
And
that's what
it's
the
like it's like we are inside of the oven, right?
uh-huh, yeah, it can be like an oven. And so cities can spend time trying to figure out how to best help the people that might be suffering from this. But there's a lot of ways you can collect data on this topic. And so I just wanted to show you a few different types of data related to the urban heat island effect, and um, how it's something that can be studied right there in your local environment. So, for example, this project I'm going to show you was done by middle school students. They wanted to study the urban heat island effect, and see, they had predicted that the rocky surfaces, the sidewalk and asphalt, would be hotter than this pond outside their school. So, these buildings here are just their school, and they went out every day in the fall and were able to go collect surface temperature measurements using an IR thermometer. And they did that for both the sidewalk and the pond to compare the data. And this is what they found. And so they had made the prediction that the sidewalk would be hotter than the pond, and the data did um, appear to follow that prediction that they had. Um, you can see the sidewalk data is shown in blue, and then the pond data is shown in orange, and the sidewalk is for the most part pretty consistently warmer than the pond. And so that's data they were able to do for the GLOBE program, for the citizen science program we were talking about earlier. They were able to go out and collect these measurements with just a small IR thermometer and contribute that data to
Mm-hmm.
the GLOBE database. This really neat example. And this is the representation that they made for their project, which is a line graph. But there's all sorts of other ways you can observe the urban heat island effect too with satellite data. And so I wanted to go into this tab here and show that using Landsat, we can get surface temperature data that's really pretty high resolution for different cities. And then we can do things like make observations about what the land cover type is beneath the surface temperature. So this is a little spyglass tool I created, but it can allow you to see what the land cover is like beneath the data. And this up here is surface temperature data, with the yellow being the hottest and the
Mm-hmm.
blue being the coolest. And so you can see that a lot of the areas with a lot of asphalt and concrete, they get much hotter than, say, the area around the river. And how you
Mm-hmm.
can see that's more green. The greener areas are cooler, and these asphalt areas are much warmer. And so that's something that can also be looked at with data that's freely available. It's just a
Mm-hmm.
different way to represent and study these types of data. And I wanted to show you just some of the ways in which this can be applied and how you can research your own environment. So in
Mm-hmm.
this lesson, we did a case study where every year, this is Atlanta, Georgia, by the way, a city in the southern United States. And every year they do this big race, okay, this big run. It's called the Peachtree Road Race. And what's shown in this pink line here, that's the route of the race. And so we gave students the task of, okay, so there's this huge race with, it's estimated 60,000 people come to run this race. So it's a big race. And they have families and people who probably want to watch the race. Where would be the best place for them to watch the race from if they're sensitive to heat? Because this happens on a
Mm-hmm.
really hot summer day. So if they're sensitive to the heat, where would they want to watch the race from in order to not be exposed to such heat? Can you identify any locations that would be the best for them to watch this race? And so the students are able to look at this data and say, oh, wow, well, it's, along the route, it's pretty hot,
Mm-hmm.
directly on the route. But there are some pockets here, where you can get pretty close to the route, but it's much cooler.
Mm-hmm.
And so people might want to stand in some of those areas to watch the race, to not be exposed so much to the urban heat island effect. And so that's one example of how these data can be used to help your community, your local environment. That
Mm-hmm.
there's all sorts of different ways in which we can use data to better understand our environment and improve things.
Hmm. That's a great thing that we can try to research something from our local area, not only about the global thing. But a question just appeared on my head. Can I share my question with you?
Uh-huh.
So like we know the challenge of our local area is not only urban heat island. We have like hurricane, air pollution, and the other thing. Like you said before, in the urban heat island, we have land surface temperature. But how do we determine the variable of one phenomenon or issue of the environmental thing? For example, for the urban heat island effect, one of the variable is land surface temperature. How we define the variable for maybe air pollution or hurricane or the other thing? Can you share the answer with us?
Yeah, it takes a lot of studying. I mean, so in order to study something like hurricanes, you have to kind of have a baseline knowledge of, what are the environmental factors that go into the development of a hurricane, or to like you said, air pollution. What are some of the different air pollutants? And once you have an
Mm-hmm.
idea of what you can monitor, then you
Mm-hmm.
can look for the data available. So with hurricanes, you could do a little bit of searching online, look at some
Mm-hmm.
different research and see, okay, how is a hurricane formed? Well, we know that hurricanes, they depend a lot on the sea surface temperature. So the
Mm-hmm.
temperature of the oceans right at the surface, and they typically form due to really warm ocean temperatures. So there's a few other things at play, but that's a big one is just warm
Mm-hmm.
ocean temperatures. And so you can use that and start to look at data um, and look at that data variable and pull data for different dates and
Mm-hmm.
things like that. Once you know the causes of a certain environmental thing like that.
Mm-hmm.
Same with air
Yeah.
pollution. You can look up what pollutants are harmful to human health that are common and
Mm-hmm.
and then look up data for those.
Hmm. That's interesting that we still did our own observation to see the factors and the other thing. So the key is just keep curious and keep asking about what actually happened in our environment. But I think that my NASA data also can help us to determine the what factor actually influenced this phenomena, because in the introduction, I think, and my NASA data mentioned some variables, right?
Oh yeah. And so I can show you a little bit about my NASA
Mm-hmm.
data and
Mm-hmm.
how it can be used to look at
Mm-hmm.
some different variables and start exploring data. Does that
Mm-hmm.
sound good?
Yeah, of
All
course.
right. I'll share my screen again. And so this is what the My NASA Data website looks like. I'll zoom in a little bit here. And so again, My NASA Data is really meant for teachers to go in and look at different. We produce a lot of lessons and activities for students, so teachers can go in and look at these and pull different lessons that use authentic NASA data. But one of the features we have on the website is a data visualization tool, and this can be used by teachers and students of all ages. And to get there, you can press the Visualize Data button or go here to Earth System Data Explorer. And when you click on that, it opens a new data visualization tool, and this can be used to look at a bunch of different variables in Earth science collected by NASA. And so what we've done here is we've tried to make it very accessible so that anyone can go in and understand this data. So I'll walk you through how to load some of the data here. So the way we have it set up is that you can select data from different spheres of the Earth system. So we have an atmosphere, biosphere, cryosphere, geosphere, hydrosphere, and Earth as a system. And so say you're interested in atmosphere data, we have all these different subcategories like aerosols, air quality, albedo, all sorts of different things. We can go into the urban heat island and you can see some of the data sets available. We have a bunch on different cloud cover, surface skin temperature, and surface air temperature. So we can select something like daytime surface skin temperature for urban heat island, and then select a date. These are mostly monthly average data, so just keep that in mind. Is they go back quite a while for date range, but they're monthly averages. But we can go into most recent data available 2024 April and load these. And then we can zoom in around the map and start to look at some of the different data.
Mm-hmm. And I can see some area covered by yellow colors, and it shows that place is warmer, right?
Yes, in this scale, hopefully it's not too confusing, but the yellow is actually warmer than the red. And so you can see like Sahara Desert's really, really warm.
Mm-hmm.
Meanwhile, the poles, the North and South Pole, are very, very cool.
Mm. Yeah.
And so that's an example of map data. And again, you can change the date. So we can go and look at different month, like December, and compare these changes. It's kind of interesting. And then we tried to add some analysis tools to help make things so that you can better analyze the data. So not just maps, but also we made it to where you can download the data and view different line plots and things. So I can go and find a location and just select a latitude and longitude by clicking anywhere on the map. Or if you know the location that you're interested in, you can put in the latitude and longitude here on the box. And then you can select your date range. Maybe I want to do 10 years worth of data. So I'm doing January 2010 to January 2024. And then if I click the Generate Plot button, it will take just a second to load. But here I can get the data now for this location for decades, from 2010 to 2024, and then we can look at the different values on the chart. We can also download these. So I can go down and click the Generate Data Table button, and it'll take just a second to load. But now I have a table with these data, with the surface skin temperature. And so we can open that in a new window. And if you give it just a second, it'll take just a second to load. But there's a download CSV button where you can download that.
And we can make our own project from that data, right?
Yep. You can make your own data from this project. See, so I opened it up in a spreadsheet and it's right there. And so you can use this data. It's accessible to you. And all of it's right here. So you can do your own research projects about your own community.
Yeah.
So that's just one example, but we have a bunch of different data sets. So you can browse through these and you can begin to look at how different variables are connected. You might be interested in the land surface temperature and maybe plant growth patterns. So some NDVI. Maybe you want to go and look at NDVI in the area. You can do the same thing, create a time plot, and then compare it to the land surface temperature. Just a couple other tools. Hold on. We have the compare to tool, so you can compare two different variables. So here, here on the left, we have NDVI, and I'll go to, maybe I'll do October 2023. And then maybe we want to do the land surface temperature on the right side. I'm going to pick the same date. So I'm going to go down to 2023, October. Okay. And then we can compare side by side.
And see the correlation between NGPI and land surface temperature, right?
Yeah, we can see it here too. Like these vegetation areas are a bit cooler than everywhere else.
Yeah.
Very cool.
That's why we need to plant trees a lot.
Yep.
Yeah. Yeah, that's really great example of how we can monitor and track the data and try to analyze the data. And I think we need to be thankful for your hard work because you provide us with open and accessible data. So yeah, last time my friend asked me about where they can access environmental data. And the thing that I know is the environmental data, but you need to pay for the credit. So um, we cannot get the full of data. And then you shared with us open, accessible, and free data sources that we can access and do the project with that. And yeah, thank you so much for sharing this thing with us. And we also have a question from someone, and yeah, my friend Muhi will share the question with you. Are you ready to meet Muhi?
I'm ready to meet Muhi.
Hi, Nikita. Hi, Mr. Desiray. I'm Mohi. Nice to meet you. We have a question from Malia. As we need to be transparent about environmental data and raise awareness, is there anything we could do to make it more appealing to the public? Thank you and bye-bye.
That's a great question. And yes, there's so many ways we can make data more appealing to the public. The first, it really is just making it more accessible. So, like we've talked about, not everybody knows how to access scientific data. So the easier we can make it for them to access it and visualize it, that will bring more awareness to it and make it more appealing for everyone to use it, and to attempt to better understand it and learn about it. Also, like we talked about earlier, making engaging graphics with it. So we really want to be good stewards of data. We want to make the best representations we can with data. We want to make them simple to understand. We want them to make sense. We do not want to manipulate the data. We want to tell the story that the data is. We want to tell the data's story. And we want to do that in an ethical way, but also in a way that conveys the information easy to understand, and appealing. We want it to look nice so that people pay attention to it and care about it. That saying, a picture is worth 1,000 words. It's kind of true for data too, and data representations. They really can help convey a lot of information very, very quickly. So it's important that we try to understand how to make it more appealing to the public and use that to bring awareness to these issues.
Yeah, I get your point that to tell people, to make people interested and understand about the data, we need to uh, make the data represent the story of what is happening, right?
Yeah.
And thank you so much for your answer, Miss Desiray. Today I got so much information from you, and I'm pretty sure that our audience, Sobat Kokamuhi, also gets so much information and so much insightful thing from you. And yeah, I'm so happy that you are here and share a lot of things and a lot of insightful things in here.
Well, thanks for
And
having me.
And before we close our meeting in here, I think we need to do something because my NASA data help us a lot. So it represents that my NASA data is superhero for us, and we can also become a superhero by analyzing the data and gain the awareness of the importance of noticing the environment from the data, right? We can also be superhero for that. So
Yeah.
let's say our jargon. So
Mhm.
I will count 1, 2, 3, and I say salam, and we say superhero together. Are you ready, Mr. Siray?
I'm ready.
Okay, let's count. 1, 2, 3. Salam, superhero.
Superhero.
And thank you so much, Mr. Siray. Thank you so much for our audience. Sobat Kokamuhi. Stay tuned to our next show and see you next time. Bye bye.
Thanks, Nikita. Bye.